Hi all, welcome to our YouTube channel Math Universe with Dr. Naseer Ahmed. Today we are going to discuss chapter Permutations and Combinations of a PUC. Since this is a very basic chapter for probability for both first year and second year, I would like to discuss each and every concept in detail. And as I complete a particular concept, if there are problems from model question paper, surely I'm going to discuss then and there itself. So make sure watch the video completely. Okay. Now let us go ahead with an example before going to the definition of both of these permutations and combinations. Okay. Now let us have a scenario that you are placed in a location A and you want to travel to a location B, but actually your destination is C. And I repeat again, I want to reach from A to C, and the medium, the path are this. Let us suppose by road 1, R stand for road 1, road 2 and road 3. Similarly, from B to C, the path is again by road, let us say road 4 and then road 5. Now the thing is, in how many different possible ways can I reach from A to the destination C? Let us try to have a count. So if I fix R1, so from A to B, R1, okay. So I have to reach from A to C via B. So first way, A to B, R1. Then after reaching B, I can take any one of the route, either R4 or R5. Let us suppose R4. So again, R1 after I reach, then from here to here, R5. So with respect to R1, we have completed the destination C, means reaching from A to C with respect to R1 done. Now fix R2. So again, if I go with R2, after reaching from A to B via R2, I can take any one of the path to reach C. So R4. It can also happen that I went from A to B, R2. Then from B to C, I went by R5. With respect to R2, that correct? No more ways. Now, if I go with respect to R3, A to B, R3, through R3 will go, and again from B to C, either R4 or R5. So let us write that. So try to count in how many ways can we move to the destination C from A. See how many are there? 1, 2, 3, 4, 5, 6. Totally 6 ways we have got. Now counting like this is a time consuming. So in place of this, do we have any other approach where we can directly comment without listing like this? We can directly comment how many such possibilities are there. Can we count? Yeah, it's recording. Yes, recording. Always I have a doubt. So how many ways can we comment directly? Yes, we can. See carefully. To reach from A to B, how many ways we have here? R1, R2, R3. So from A to B, we have 3 ways. How come 3 ways? R1, R2, R3. Then from B to C, how many ways? 2 ways. R4 and R5. Nothing but 2 ways. Therefore, total number of ways to reach from A to C will be product of this 3 into 2, nothing but 6 ways. And that's what we got, 6 ways. This we call fundamental principle of counting. In this we have got 2. One is with respect to multiplication rule. what this multiplication rule says. Listen carefully. This rule says if an event can occur in m different ways, following which another event can occur in n different ways, then the total number of occurrence are m into n. But for this, this multiplication rule is acting like and. Nothing but both should happen. Now, for example, you see this diagram. To reach from A to C, first I have to come to B. After coming to B, the intermediate between A and C, after reaching B, then I can go to C. So until unless I won't come to B, I cannot go to C. So both should happen. That's what and. Only then we will take multiplication rule. Now, one more scenario. See carefully. Same diagram. First, I hope this is clear. Again, I repeat. From A to B, 3 ways. B to C, 2 ways. Total number of ways is 3 into 2, nothing but 6 ways. What multiplication rule says? If an event can occur m ways, followed by another event occurring n ways. I use the word followed, nothing but first this should happen. After this has happened, the next event should also happen. Okay? Then, if an event can occur m ways, another event can occur following this, another event can occur n ways, then the total number of ways m into n. Similarly, let us suppose that this is for 2 events. We can have for 3 also. What if an event can occur m ways, followed by another event can occur n different ways, and one more event can occur p different ways, then the total number of occurrence will be product of the 3. Like this, we can generalize n number of ways. But finite, surely finite number of occurrence should be there. This is called multiplication rule. Now, see carefully. Same thing, I will take it here to avoid confusion. A, B, C. Same, okay? R1, R2, R3, R4, R5. No change, right? Now one more way, one more path to reach A to C. Let us suppose aeroplane. Okay, A, okay, is already used. So I'll just say a path R6. A direct road we can say. It's looking like a mask, no? Okay, fine, anyway. Now just count how many different ways. Let us try to list out. Then we will talk about one more rule. Coming to the one which is there in the black, nothing but R1, R2, R3, R4 and R5. Way to reach from A to C, I have to go through B. It is same as what we have listed here. So no change. So A to C. A to C. Let's just copy it on this itself. So I'm going to have R1, R4, R1, R5, R2, R4, R2, R5, R3, R4, R3, R5. So to reach till here, correct? No, but now see carefully. This path is nowhere going to depend on B. Directly it can go. So it is R4. Sorry, R6. I mean to say R6. How many ways we have got count? 1, 2, 3, 4, 5, 6, 7. 7 ways we have. Now listen this rule. This event to reach to C from A, B is required. So when I'm going to go from A to B, then B to C to reach C there. So here 3, then into 2, correct? But since this is of AND type, correct? But when I go from here to here, it is what? OR. Nothing but without going for this path, R1, R2, R3, R4 and R5, then also directly I can reach to C from A. So since I'm not going to depend on that, since now there is nothing like AND, it can be OR. As soon as I say OR, plus. How many ways? Only one way. So answer will be 3 2s are 6 plus 1, nothing but 7 ways. And this we call addition rule. in NCERT we don't have a separate definition for this, but we are using while solving the problem. Okay, especially 5-marker problems. So what this event or what this rule says, if an event can occur m ways, if the event can occur m ways, another event can occur n ways, then the total number of occurrence will be m plus n ways. Okay, here all are feeling should come. Nothing but I have a choice. Whenever we have a choice, then comes plus. Whenever we don't have a choice, whenever it is and, then it is what? Multiplication. Okay, so I hope this logic is clear. M into n base. Now with this, let us move on to some basic problem on this. Kindly make a note of this. Dear students, having completed fundamental principle of counting concept, let us try to take an example. And here I will be trying to take an example with respect to alphabets, where we have to arrange the alphabet, so that when we take problems on numericals, nothing but arranging 3-digit number or 5-digit number, there is a lot of confusion for the student. So let us try to get clear, okay, idea from this. Pay attention. Let us suppose that question is, Q means question from my end, okay. Question is, arrange two objects from A, B and C without repetition. This is our first part of the problem, and second part is with repetition. The entire game is here only. Understand carefully. Okay. Now I have got arranged two objects from A, B, C. There are three objects. Okay. So I have to arrange without repetition, with repetition. So first the objects are A, B and C. Now coming to what they said, without repetition. Now since I want to arrange two objects, how many boxes I will take? Two boxes I will take. Number of boxes depends on how many objects we have been asked to arrange. Now whatever the number I am going to write here, it stands for number of objects that can fit in. So how many objects we have got? 1, 2, 3. Any one of the three objects. So this 3 stands for either A or B or C, anyone. And since I said without repetition, I am going to fix one of the objects here. Let us suppose among A, B, C, okay, B gone. B gone. You can fix any one of your choice. Now coming to this box. Now since B is fixed and repetition not allowed, repetition without repetition, so repetition not allowed, either A or C should fill in. So we have two objects. So that will happen simultaneously. So the number of A will be 2 into 3, that is 6 ways. Now some students have a confusion. How, sir? For that purpose, what we can do, let us try to manually list out. Okay. So I have got how many objects? 3 objects. I want to arrange how many at a time? 2. So let us suppose I am going to fix A. When I fix A, okay, since I use the word arrange, okay. So just see carefully. Carefully you see. This is also going to give a clarity for permutations and combinations as well. And coming to the marks, no, one 5-marker question, and this we can expect as 8 plus marks. Okay, better 7 to be safer side. 7 plus marks. So out of this, any 2 objects, correct? Now 2 objects we have to take. So let us fix A. So I can arrange with A, B or C, A, C. So with respect to A, arrangement done. Next, it can happen that with respect to B, I can arrange A, B, A, or it can be B, C. Now with respect to C, I can arrange C and A, nothing but C, A, then C, B. And one thing is very clear, these two are not equal. In arrangement, they are different. Arrangement you can think as ranking system. When I say first rank person A, second rank is person B. So it means order is important. Okay, order is important. So again, how many ways we have got? How many ways we can arrange? 1, 2, 3, 4, 5, 6. Totally 6 ways. That's what we have got here. Here we have manually list out, but here direct concept of fundamental principle of counting of multiplication, because one event is following the other. Okay. Now here it is without repetition. Now it is move on to with repetition. Now it is move on to with repetition. So again the same objects given, 3 objects, and I want to arrange only 2. So A, B, C. Since 2 objects, how many boxes? 2 boxes. Now here any one of the 3 can fit in. Let us suppose, now 3 stands for number of objects. Let us suppose in that C gone. Now since they said with repetition, so whatever the object I have fixed here, that also can be used. So again, how many are there? 3. So by fundamental principle of counting, 3 into 3, 9 ways. Listen carefully. Now I'm going to list out with repetition to have a very clear concept. Okay, let us move on. A, correct? No. B, C. I have to arrange. So arrangement. A, I can fix A. Now see carefully. A, B, A, C. Correct? No. A, B, A, C. Same as what we got here. Next, if I fix B, B, A, then B, C. B, A, B, C. Now C, with respect to C, C, A, C, B. C, A, C, B. And again, they are not equal. So what is the difference? You got same only. You got 6 only. No. Repetition allowed means I can arrange in first place A, second place also A. I can arrange B, again B, then C, again C. These 3 were not there here. Why? Without repetition. So now count totally how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. Totally how many ways? 9 ways. That's what we got here. So I hope the things are clear. First make a note. Dear students, purposefully I have went for alphabets, which is nowhere in the NCERT text, to make you understand that the problem which I'm going to take, when I'm writing anything here, it is not the numbers. It is the number of objects that can be fitting in. Okay? Number of objects that can be fit here. I hope this is clear. As soon as it is without repetition, as soon one object is fixed, no, the quantity will reduce. But in without, I mean to say with repetition, it will remain the same as number of objects. Okay? So now let us take problem from NCERT. Okay? Make a note of this. Dear students, let us move on to the next problem. And I have taken this problem from exercise 6.1 and I have given the same numbering, okay, as per the textbook. Question says, how many 3-digit numbers can be formed from the digits 1, 2, 3, 4 and 5, assuming that there are 2 conditions. First one, repetition of the digits allowed. Second, sub-problem, repetition of the digits not allowed. So, we will be understanding better the fundamental principle of counting. Okay, listen carefully and see. This is the one chapter where it will make us more to speak than write. Writing part, I'm expecting that you are going to fill yourself. Only I'm going to go for the solution part. See this carefully. First part, repetition of the digits allowed. What we want? 3-digit numbers. So we will have 3 boxes. The first box rightmost is for unit digit, then 10 digit and then 100 place. Okay. Now, which are the digits? 1, 2, 3, 4 and 5. And they said repetition allowed. Okay. So it means that if I have used one digit, again I can repeat the same digit. Okay. So now, coming to the see whatever we're writing here, it is number of objects. Think all this as objects. How many objects are there? 1, 2, 3, 4, 5. Now here I can fill any one of the 5 objects. Any one of the 5 objects. This 5 is not this 5. This 5 is the count of how many objects I have got to be written here. Okay, let us suppose in that 5 objects 4 is placed here, one of the object. Okay, now when I'm going to fill here in 10th place, again observe the question, repetition allowed. Since repetition allowed, it means here when I fill 1, 2, 3, 5 as well as 4 also can be filled. So again any one of the 5, all the 5, any one of the 5. Similarly in 100 place also any one of the 5. Now you can see all has occurred, means followed each other. So by fundamental principle of counting, I can multiply 5 into 5 will be 125 ways. So we can arrange this in how many ways? 125 ways. When I'm saying repetition is allowed, it means we can also have from here a digit like this as well. See, this 55 is repeated. Or we can also have this scenario. Okay, so what is this? 11,111. Okay, now comes second, repetition of the digit not allowed. Not allowed. Second sub problem. So again I want 3-digit numbers, so we'll have 3 boxes. So here we are going to have unit, then 10 and then 100. Now coming to this unit place, always start from unit. Okay, how many digits are there? 1, 2, 3, 4, 5. Only 5 digits. Now see carefully. I can fill here any one of the 5. And again I'm saying this 5 is not this number. This stands for number of objects. Write it here. What is number stand for? Number of objects. Let us suppose in that 3 gone. You can say whichever you want, that is gone. Okay, it's not going to alter the numbers going to be 10 because here it is number of object, not the object, number of object. So here now 1, 2, 3, 4. I repeat 1, 2, 3, 4. So any one of the 4 object. Let us suppose in that 1 gone. Again, since the repetition not allowed, so I should not take 1 and 3. So how many objects are remaining? 2, 4, 5. 3 objects, no? So now multiply by fundamental principle of counting. 3 into 4 into 5. 3 4s are 12 into 5 will be 60 ways. And compared to this, now we have a less number of ways. Why? We are not covering this part where repetition is allowed. So all the numbers, 3-digit number, whichever I am going to have. Okay, here I think when I gave the example, no, I could have just given 2 digits for a while, means 3-digit. It should be like this. I have given 5-digit example. It should be what? 3-digit. Right? No, 3-digit numbers, only 3-digit. Okay. So here also the scenario can be like this. So example, that we will have this type of numbers in this arrangement. Okay. I have taken all our numbers type. Now just see, here it is 3-digit number, but here it is 3-digit even numbers that can be formed from the digits 1, 2, 3, 4, 5, 6 if the digits can be repeated. But here I want even digit. Now to understand now this problem, first answer some of my question. I will just write 3-digit number. You should say whether it is even digit number or odd digit number. What do you think? 221. Is it even or odd? Which type of number it is? Even number or odd number? Don't forget, unit place number will decide whether it is what? Even or odd. This is your unit place, this is your 10 place, and this is your 100 place. So since one is odd, so it is not even number, not an even number. Not an even number. Next, if we have 372, our unit place digit is even. Since this is even, so the entire 3-digit number is even number. So summary of the story is unit digit place, whatever the number is there, that will decide whether it is even or odd. Since I want it to be what? Even numbers, and digits can be repeated, nothing but repetition repetition allowed. So unit, 10, 100. Now here which other digits are there? 1, 2, 3, 4, 5, 6. Now the thing here is, try to understand in unit place which are the digit we can place. Here, since they didn't say even digit number, so we didn't have any condition to fix. We can take any one of the 5 non-zero digits, nothing but objects here. But here, since they have said it should be even, so which are the even numbers among this? The even numbers are 2, 4, 6. So here, any one of these 3 can be fixed because I want 3-digit even number. In that, let us suppose 4 is gone. And they said repetition, if the digits can be repeated. So nothing but repetition allowed. So here, 4 is out. Even though 4 is out, and since repetition is allowed, again I have got how many objects? 1, 2, 3, 4, 5, 6. So 6 objects I have got. Again I have got 6 objects. Same whatever the logic I said here. So by fundamental principle of counting, I can go for multiplication. So 6 into 6 into 3. 6 6 are 36 into 3. 3 6 are 18. 3 3 are 9. 10. So 108 ways. Purposefully I have taken all the problems on numericals. Nothing but we are arranging a 3-digit number, 4-digit number like that. Now you see this. How many 5-digit telephone numbers can be constructed using the digits 0 to 9? If each number starts with 6, 7 and no digit appears more than once, no digit appears more than once. What's the meaning of this? No repetition. No repetition. Repetition is not allowed. Now, since I want 5-digit number solution, so I will go for 5 boxes. And one more thing I would like to bring to your notice. Here they have said 0 to 9. They may not give. Suppose they have not mentioned the digits. Let us suppose the way they have mentioned here, which digit here, which digit here, which digits to be used. Let us suppose they have not mentioned any digits. Then question is not wrong. You are going to take 0 to 9 whenever digits are not mentioned. Reason, whichever number you take, 1-digit number, 2-digit, 3-digit, whatever number of digits, digit number, it is going to have numbers between 0 to 9. So it is obvious. It's a common sense. Don't think no question wrong will get grace marks. Okay. Now come here. How many 5-digit that can be considered from 0 to 9? No repetition. But here they give one condition that if each number starts with 6 and 7, 6, 7. So start. See this. Unit, 10, 100, 1000, and here it is 10,000. Correct na? 10,000. So see carefully. Now when I'm going to go ahead with this, here this is 6, start with 6 and 7, nothing but this is always fixed that it should be 6. This is always fixed that is 7. So in place of giving cross, no, try to understand. Here, this was talking about number of objects that can be filled, here. Now here, I can only fix a 6 here, nothing but how many objects are there? Only one object. Only one object. Here 7 is fixed. How many objects are there? Only one object. So whatever we are writing inside the box, those are what? Number of objects. Now let us list out all the numbers between 0 to 9. Now in this 6 and 7 is out. Why? Repetition not allowed. So this number is out. This number is out. Now in 100, 110 and unit place, I have to fill the remaining without repetition. Now how many digits are there? Count 1, 2, 3, 4, 5, 6, 7, 8. Correct? So any one of the 8. In that, let us suppose 0 gone. So remains how many? 7. Let us suppose in that 8 gone. Nothing but the digit is fixed. Okay, and it is out because repetition not allowed. Next, remaining is 7. So again, sorry, remaining is 6. No, repetition not allowed. So 6. So number of way will be 6 into 7 into 8. Sir, what about this? Okay, right? 1 into 1. Okay. So what is the answer? 1 into 1, 1. Okay. So 6 into 7 into 8. So multiply 6 is 42 into 8. 8 2s are 16. 8, 16, 24, 32, 33. 3, 3, 6 ways we can have the telephone number starting from 6, 7 or 5 digit, where repetition is not allowed. Now for you the assignment will be let us suppose repetition is allowed. Everything is same. Repetition allowed. What is the answer for this? Similarly here they said repetition is allowed. Without repetition, what is the answer? Okay, let us see how many can comment on that. Okay, make a note. Naseer, be careful. We have finished 3 problems from exercise. Okay. Dear students, having understood the concept and the problem from the first exercise, let us move on to next concept, that is factorial notation. First, we will understand factorial notation. Okay. Now, let us suppose that I have got 3 factorial. The meaning of this is, first we are going to read this as 3. This exclamatory mark we will read as factorial, and it is 3 into 2 into 1. Observe this carefully, right to left. Whatever number is there, write down, and you have to reduce each number by 1 till you reach 1. So in place of writing like this, we write 3 factorial. It's just a notation. And multiply 3 into 2 into 1 is 6. Meaning behind this we will talk, but first understand how to compute. Next, let us suppose I will have 5 factorial. So number is 5. So start with what? 5. And you have to write till 1, reducing 5 by 1 each. And you should multiply 5 into 4 into 3 into 2 into 1. 5 into 4, 20. 20 into 3, 60. 60 into 2, 120. 120 to 1, 120 itself. And this is only defined for what? Whole numbers. Whole numbers. It means 0 also. Yes. 0 factorial is 1. Surely I know how, sir. Sabar. I'll give the explanation for that. And similarly, 1 factorial will be what? 1. So it means if I got n factorial, so this is just for example, see this, in place of 5 we have n here. So whatever number, same number, so n. Then the next number, I'll give a bracket in place of cross into here. Here 4. 4 is what? 5 minus 1. Reduce by 1. So reduce by 1. N minus 1. Again, the next number is 1 less than the 4. So 1 less than this will be n minus 2. Again, next number will be 1 less than this, nothing but n minus 3. Like this, you should go till you get 1. This will be n factorial. Okay, fine. Now, having understood this, let us understand the meaning behind this. See carefully. As we just discussed before the exercise problem ABC I took, and I said arrange 2 objects out of the 3. Now, the same problem I will take to make you understand. I have got arrange. Question is arrange all 3. Question from my end. Okay, arrange all 3 objects. Which one? A, B, and C without repetition. Without repetition. We have to arrange all this without repetition. Now just do it. First, I will take again that box concept which I have explained. Then we will try to relate with this. So how many objects are there? 3 objects. So I want to arrange all the 3 objects. So 3 boxes. And which are the objects? A, then B, C. So here any one of the object can be filled. And they said without repetition. So let us suppose in this A gone. So here either B or C. So two objects. Let us suppose in that C1. Now here only one is left, B. So only one object. Now multiply this 1 into 2 into 3. Nothing but what? 6 ways. And what is this? 3 factorial. Oh. What's the meaning? Factorial represents number of ways of arranging n distinct object without repetition. All n distinct object. Let I repeat. Write it here. What it represents? It represents arrangement of n distinct, nothing but different, distinct means different objects without repetition, taken. It represents arrangement of all. Then this is not required. Arrangement of what? All n distinct, nothing but different objects without repetition. So I am going to, whenever I say arrange, I got 8 objects. Arrange all 8 objects. Answer is what? 8 factorial. And multiply. How you like? 8 into 7, 6, 5, 4, 3, 2, and 1. Then multiply like the answer. Assignment for you. Okay. So like this, we can go ahead. Now let us try to understand why is 0 factorial 1. Here it means I don't have, n stands for number of objects to arrange. 0 factorial means I don't have any object to arrange. So now how many ways can I arrange the object which I don't have? I can't arrange them. Correct? No, just leave it. Nothing but one way. Leaving them. Okay, which I don't have. So one way. Okay, so as a standard we can remember always it is 0 factorial is 1. Now having understood this, one question I want to take from NCERT for a while. Yeah, dear student, this problem I want you to understand thoroughly. Okay, they're asking, is 3 factorial plus 4 factorial, I repeat, 3 factorial plus 4 factorial is equal to 7 factorial? We have to check. Fine. Solution. Having understood that n factorial represent arrangement of all n distinct, nothing but different objects without repetition. Okay. 3 factorial means what? Arranging all the 3 objects without what? Without repetition. So 3 factorial plus 4 factorial, this stands for arranging all the 4 objects without repetition. So this will be how much? 3 into left hand side I am talking about. 3 into 2 into 1. 4 factorial is 4 into 3 into 2 into 1. 3 into 2 into 1 is 6. 4 into 3 is 12. 12 into 2 is 24. 24 into 1 is 24. And this we will get 30. This is our left hand side. Okay. That is, I'll take as equation number 1. Now consider the right hand side. 7 factorial. 7 factorial, nothing but arranging how many objects? 7 objects without repetition, and all the objects are arranged. That's what we call permutations. What is permutation? Arrangement of all or some object in a particular order, in a definite order. It can be all the object or some object. Okay. Now 7 factorial is what? 7 into 6 into 5 into 4 into 3 into 2 into 1. Now just multiply. See carefully. 1 2s are 2, 2 3s are 6. 6 into 4, 24. 24 into 5, how much? 120. 120 into 6. How much? 6 0 0, 6 2s are 12, 6 1 are 6, 7. So till here 720 into 7. So I have to multiply this 7. 7 zeros are 0, 7 2s are 14, 7 7s are 49. So borrow 1. If we add 5040 is, this is equation number 2, right hand side, is 30 is equal to 5040? No, they are not equal. So I can conclude that 3 factorial plus 4 factorial is not equal to 7 factorial. And this problem is so good framed. Should not happen, no? Student will think, no, factorial is common. So why I have taken this problem? First of all, understood that it's not equal. Why I have taken this problem? Should not happen, no? Student will say left hand side is 3 factorial plus 4 factorial. Common is what? Factorial. Then what? 3 plus 4. How much? 7 factorial. Yes, sir, I got it. So I hope you understood the logic. That's why I give this logic here. And it's very clear that this is wrong. Why? It's not a product of two terms. See, like this you can take common if you have product of two terms. This is not a product of 3 and factorial. 3 factorial represents arranging all the 3 objects without repetition. 4 factorial stands for arranging all 4 objects without repetition. And this 7 factorial stands for arranging all the 7 objects without repetitions. Okay? I hope this makes sense. Make a note of this. Okay. Dear students, let us move on to question from model question paper from, okay, I repeat. Dear students, let us move on, Dear students, let us move on to model question paper problem from model question paper number 1. Question number 6 from PUC 2024-2025 academic year. Question says, if 1 by 6 factorial plus 1 by 7 factorial is equal to 8 by, I repeat, 1 by 6 factorial plus 1 by 7 factorial is equal to x by 8 factorial, find the value of x. X is here. So see, don't think of multiplying this one and simplifying. You have to just make sure, remove factorial. So in this, which is the least number among 6, 7 and 8? 6 is the least. So retain that one as it is. See the logic. Listen the logic. First I will copy the question better. And be careful, many will have a doubt, sir, should we prove it or assume it? You should assume if it's given. If you assume this equation, only then you can find the value of x which is asked here. Okay. Now in among the 3, 6, 7 and 8, 6 is smaller. So keep as it is, the factorial. 7 factorial, I can write as 7 into 6 factorial. Similarly, 8 factorial we can write as 8 into 7 into 6 factorial. Now see very clearly, something is getting cancelled throughout, or I can say multiply by 6 factorial. So this will get cancelled, this will get cancelled, and cancelled how? Multiply by 6 factorial. Now what is remaining? So before I go ahead, whenever you have factorial, try to remove that. How to remove? See, among all, which is the smallest, try to express in the terms of smallest number. Okay, in terms of factorial. So now here 1 plus 1 by 7 is equal to x divided by 8 into 7. Now fraction, take the LCM. Nothing is means 1. LCM of 1 and 7 is 7. 7 by 1 is 7. 7 into 1 is 7. Plus 7 by 7, what? 1. 1 into 1 will be 1 is equal to x divided by 8 into 7. Very clearly, we can see that 7 by 7, means 7 and 7 is getting cancelled on either side. Then what is remaining? 7 plus 1, 8 is equal to x by 8. Cross multiply, 8 8s are 64. The value of x is what? 64. Option C is correct. Okay. Kindly make a note of this. Okay. Dear students, having understood the concept of factorial notation, now let us move on to the definition of permutation. As I said, concept clearance is very important. You should have a very crystal clear, clarity about the concept. Permutation is an arrangement in a definite order of number of objects taken some or all at a time. I want you to understand this one word here and this entire sentence. I want arrangement. So it means that if I take A, B and C, I'm repeatedly quoting this only. 3 different objects I have got and I want to arrange them. And I can take all or few, nothing but some out of this. Now, factorial concept we have understood that it is arrangement of all the object, but it should be distinct object and without repetition, correct? So directly if at all I take all the object for arrangement, all objects for arrangement, since I've got 3, so answer is 3 factorial, which is 6 ways we can have the arrangement. Now the question comes, what if I want to take few objects, not all, I want to take some objects, then do we have any formula? Yes, we have. It is NPR is equal to n factorial divided by n minus r factorial n minus r factorial. Now, where n stands for total number of distinct object. Here the most important, the object should be what? Different. The object should be different. Total number of distinct objects. What about R? R stands for number of objects taken for arrangement. Okay, number of objects taken for arrangement. Now here itself, when I am saying number of objects taken for arrangement, one thing is very clear, that the R value can go from 0 to n. 0, none of the objects are taken for arrangement, or it can be in between n, or it can be equal to n also. So having this, let us try to understand the point one by one. Let us suppose that point 1, I'll take this as equation number 1, this entire expression. If I say R is equal to 0, what's the meaning? Out of n object, I don't want to arrange a single object also. Then what will be the answer? Just substitute here in equation number 1. If I substitute here, np0 is equal to n factorial divided by n minus 0 factorial. So n factorial divided by n minus 0 is n, then factorial. So both will get cancelled and I'm going to get the value of np0 to be 1. What is the meaning behind this? Understand. I have n objects, for example 5 objects, and I don't want to arrange them. Now see, when I'm saying I don't want to arrange them, even though I don't want to arrange them, they are already in one particular manner, one particular order. For example, let us suppose when I enter the class, students, I want to, now my question, now with respect to me, whether I want to rearrange the student before taking the class, or I want to retain them as it is. Now as soon as I enter, let us suppose now I want to complete the syllabus, and okay, I just say student, settle down wherever you are. Now I have not went for arrangement, correct? No, even though I have not went for arrangement, but student are already in one particular arrangement. That's what n stands for number of students, and I have not arranged them. Even though I have not arranged them, they are already in one particular arrangement by themselves. Okay, that's the reason it will be 1. I hope this logic is clear. Similarly, what if R is equal to n? Nothing but I want to arrange all the objects. Let us see who will think before we solve. Already we have discussed this. Let us see who will think. If I put here NPN, this is our second point. NPN is equal to n factorial divided by n minus n factorial. What is n minus n? 0 factorial, and here n factorial. 0 factorial is 1. So I will get n factorial divided by 1. Any number divided by 1 is what? Same number. And this already we discussed in factorial notation, that number of ways of arranging all the n objects, distinct n objects, is n factorial itself. That we can see from here also. And I would like you to remember the standard result. Anyway, if you forget also, always you can derive like this. Now, this formula, I have said total number of distinct objects and number of objects, whatever. Now here, most important, this formula is going to work for without repetition. Without repetition. Let us take one example which we have already went for. We have taken 3 objects, no, A, B, C, and we also took at the beginning 2 objects I have taken. That's was 6 only, correct? Let us see, can we get the same thing from this also? So one example problem from my end, one question. Let us suppose I have got A, B and C, and I want to arrange only 2 objects. So here you see how many objects I have. Totally 3 objects, total number of objects. How many objects I want to arrange? 2 objects. So answer will be now NPR formula, that is n factorial divided by n minus r factorial. N is 3, r is 2. So 3 factorial divided by 3 minus 2 factorial. 3 minus 2 is 1. 3 factorial is what? 3 into 2 into 1. So answer is 6 divided by 1. Therefore we get 3p2 is equal to 6. 6 ways we can arrange, that we already saw, right? So this is for whenever it is without repetition and n are distinct objects, only then we are going to use this. Now one question will come, sir, what about with repetition? Do we have any concept for that? Let us take it here only. Again, as a note we can take, let us suppose that I have got n distinct objects. Totally I have got n distinct objects. Distinct what? Different objects. And I want to arrange only r objects. R objects to be arranged. But here the condition is with repetition. With repetition. So how to go about? Very simple. The formula for this will be n power r. So about the logic, let us try to take an example and understand. Let us suppose that I have here how many? 3 objects I want to arrange, and here it was without repetition, correct? No, without repetition. Now I want to go for with repetition. So since I want to go for with repetition, let us understand this with the help of that box concept. See carefully. Since I want to arrange how many objects now? 2 objects only, but with the repetition. So 2 boxes. Here we have 3 objects. Any one of the 3 objects. In that, let us suppose B is gone. But again, since repetition allowed, let us even B is also taken into consideration. So again I have 3 objects. What is 3 into 3? By fundamental principle of counting, 3 square. Now understand carefully. What was 3 here? Total number of objects, n. And what is 2? R. So this will be the formula. Who knows for 1 marker? They may ask. So make a note of this. Okay, having completed some of the concepts from permutations where all the objects were distinct, what if we have got identical objects? I mean to say that a word is given in that some letters are repeated. Okay, for that let us first understand the concept. Here I have taken the exact theorem from the NCERT text, and here the heading for us is permutation when all the objects are not distinct, nothing but different. The objects are not different, they are some identical, same type. So in this we have two theorems. Let us suppose that the theorem number 3 says the number of permutation of n objects, but this n objects don't have all the objects to be distinct. There are some p objects are of same kind and rest are different. Then what's the formula? Formula will be n factorial divided by, since there are one kind of objects, p kind of, I repeat, there are p objects of the same kind, so whatever number of objects are of the same kind, that should be divided. Okay, first let us understand, then we'll take a problem to understand how to solve it. Next, here we have said only one objects, means p objects of same kind. It may also happen that out of n objects, I have got p1 objects of one kind, p2 objects of second kind, like this pk objects of kth kind. Then, and let us suppose that remaining are different, then what could be the permutation? Nothing but arrangement. For that, let us write the answer here. Since total number of objects are n, so answer will be n factorial, and since p1 objects are of same kind, so p1 we are going to divide here, factorial. Then p2 objects are of second kind, so p2 factorial. Like this will continue till we complete what? Kth, pkth objects of a kth kind. So whichever it is repeated, that should be divided. Now to understand better, take this problem. Find the number, I repeat, find the number of permutations of the letters of the word Allahabad. So permutation means, as we discussed already, it's arrangement of objects taken some or all at a time. So here coming to solution, we want for Allahabad. Now see, you have to be very careful in examination. They are not going to give any hint for you that you have to use this concept of the previous one. Previous, when I took ABC, none of the letters were repeated. Now here you see, some of the objects are repeated. See in Allahabad, see A. Coming to A, see how many A's are there in Allahabad? 1, 2, 3, 4. So A is repeated 4 times. Okay. Next you see L. How many times? 1, 2. So L is repeated how many times? 2 times. Then what next? Any other letter repeated? H, nowhere, nor D. Okay, fine. Now count how many letters are there in the word Allahabad. Count it. 1, here 2, then this 3, 4, 5, 6, 7, 8, 9. Therefore, the permutation will be, as you can see, total objects n factorial. So here it is 9 objects together, so 9 factorial, in which A is repeated 4 times. So divided by 4 factorial. L is how many times? 2 times. 2 factorial. This will be the permutation. Now let us simplify. When we are going to simplify, see carefully, here we have 4 factorial. So we can write 9 factorial as 9 into 8 into 7, 6, 5 into 4 factorial. So whole divided by this 4 factorial. I purposefully stopped here so that we can cancel 4 factorial very easily. Then 2 factorial same as 2 into 1. So simplify this also. 2 1s are 2, 3s are 6. So remaining, let us write down 9 into 8 into 7 into 3 into 5. So we have to calculate 8 9s are 72, correct? Then into 7 it is. So 7 2s are 14, 7 7s are 49, 50. Then into 3, so multiply into 3, 3 4s are 12, 3 5s are 15, then into 5. So okay, into 5, multiply 5 2s are 10, borrow 1, 5 1s are 5, 6, 5 5s are 25, so borrow 2, 5 1s are 5, 6, 7. So the number of ways of arranging the word Allahabad will be 7560 ways. This many ways we can arrange it. Now, I just want you to understand one more way. Mean to say, when all the n objects are distinct, so is it why it is not that we are not dividing any as such? Actually, we are dividing. I mean to say, let's take one example. Let us suppose that I take one word. Okay, what word we can? Ahmed, my name, surname, Ahmed. I want to arrange this word taken all at a time. So none of the letters is repeated. So here 1, 2, 3, 4, 5. So answer is 5 factorial. Yes, we know. But can we apply this logic also? Actually speaking, no. Here none of the letters, all the letters of one kind, nothing but they are not repeated. So I can also say it's divided by for A. Since A is only once, 1 factorial. H is only once, again 1 factorial. M is only once, again 1 factorial. E is only once, again 1 factorial. D is only once, again 1 factorial. Again I'll get 5 factorial, which is 120 ways. So actually speaking, there also we can think of applying this logic. But since none of the letters are repeated, it is divided by 1 factorial. And 1 factorial is what? 1 itself. So there is nothing to divide and show. Okay, I hope this is clear. And coming to this also. Now for example, here H and B, D are not repeated. They are present only once. I can also into 1 factorial, into 1 factorial, into 1 factorial. I just thought now that I just share this. Okay. Now we'll start with the model question paper problems on this. Okay. Make a note. Okay. Dear students, now let us take the problems from model question paper. And this is from model question paper number 1. Let I once check. Yeah, it is from model question paper number 1 and it's a 5-marker question. Be careful, usually 5-marker question is from combinations, but in model paper it has come from permutations as well. Question says, in how many ways can the letter of the word permutations be arranged if there are 3 sub-questions. Words start with P and end with S. Second sub-problem, vowels are all together. Third sub-problem, there are always 4 letters between P and S. See, what I will try to do now, I'll first solve first and third sub-problem because both are same type. Then we will take a second sub-problem. So coming to the solution of this problem, they want us to arrange permutations word. See, permutations. See carefully. First, after writing check with the question, have you written the word correctly? Now coming to the sub problem number 1, words start with P and end with S. Let us try to solve with the box concept because in box, no, since we are manually writing and understanding, no, that will be very clear and we will not do any errors. First count how many letters are there? 1, 2, let us write it. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Since 12 letters are there, I want 12 boxes. And listen carefully because for third sub problem, first problem is the base. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Check it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. See, when you draw the line, no, as soon as you come 11, no, it means you have got 1 box extra. Okay, fine. So they said start with P. So this particular box is always fixed for P, and they said start with P, so it is fixed for the first one, and end with S. This is always fixed for S. Now whatever I have to arrange from here till here. So it also means that in the word permutations, P is already arranged, S is already arranged. So I have to arrange the remaining. So remaining nothing but permutation. Permutation. See how many letters are there. Easy, no? Totally 12 were there. In that, 2 are out. So how much is 12 minus 2? 10. So remaining are 10 letters. And just see, is there any letters repeated? That's very important for us. Is E repeated? No. R, M, T. Yeah, T is repeated twice. T 2 times it is repeated. Correct? Any other? E, R, M, U, T, T, A, T already over, I, O, N. Yes, only this. Totally we have 10 objects. So answer will be 10 factorial divided by T repeated twice. So 2 factorial. So let us simplify. What will be 10 factorial? 10 into then 9, 8, 7, 6, 5, 4, 3 into 2 factorial whole divided by this 2 factorial. That will very easily cancel with the numerator. So 3, 4, 5, 6, 7, 8, 9, 10. Now we have to multiply. So let's multiply. See carefully. Let's start from here. 10 into 9, 90. Okay, 9 into 8 is 72. 72 into 10 will be 720. Correct? Then into 7 I have to multiply. Anyway, calc is allowed for you. 7 0 0, 7 2s are 14. Borrow 1, 7 7s are 49. Borrow 1, 50. Into 6. Okay, 6 for 30, no? So into 30. So what will happen? 3 4s are 12. 3 0, borrow 1. So I'll get 1 here. 3 5s are 15. And we have 2 zeros here. So I can have 2 zeros there. Next. 4 into, okay, 4 into 3, 12, no? So, okay, into 4 first we'll do. So 4 0 0, 4 0 0, 4 2s are 8, 4 1s are 4, 4 5s are 20, 4 1s are 4, 5 6. Okay, then into 3. So what's the final answer? 3 0 0 0 3 8s are 24, borrow 2, 3 4s are 12, 13, 14, 3 0 0, borrow 1 is there. So 0 plus 1 is 1, 3 6s are 18. So answer is 18,14,400 ways. This many ways we can arrange. 18, 14, 400. Okay. Okay. Ways. Okay, ways. And don't forget to explain the things in your own words. Okay. That the first 2 letters are fixed. So number of ways are 1. Then the remaining word permutation has got T repeated twice, hence number of ways are. Then the solution. Now come to third sub problem. Try to understand the difference between first and third. Is it recording? Oh yeah, first and third. Here they said words start with P and end with S. So they gave the exact location of P and S. Whereas third sub problem, there are always 4 letters between P and S. So they are not specifying any particular location. They are just saying between P and S, 4 letters are required of the word permutations again. Okay. Now see carefully. Let us take that problem here. And again, as I said, no box way. If we understand, things are very clear. So let us write first the word permutations. Now in this, what they are saying, I should have 4 letters between P and S. So see carefully. Again, I will have total number of boxes to be 12 as usual because we had 12 objects. So see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. As soon as I say 11 sufficient, distribute with the box. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now they are saying in between P and S 4 letters should be there. Now see carefully. I'm not going to write P here. See, if I fix P here for a while, just see. Now leave 4 boxes empty. 1, 2, 3, 4. S should be here. Why? They said there are always 4 letters between P and S. Now see carefully. They just said between P and S 4 letters. They didn't specify that P should be at the first or S should be at the last. So it means to say that first is, as soon as I fix this P and S here, remaining word, which is that permutation. Permutation will be again arranged in the same manner, nothing but 10 factorial divided by 2 factorial. I hope this point is clear. As soon P is in the first and S is in the 1, 2, 3, 4, 5, 6th location. And in between them, how many objects should be there? 4 objects. 4 objects. You can see here. 4 object space is left. But now listen carefully. After we finish this, listen carefully. It can also happen that P is here. As soon P is here, I have to leave 4 boxes empty. 1, 2, 3, 4. So S will be here. So this is one more way. So mean to say that, let us write it here. For this black color, P and S, that is one particular way. Now I can have P here and S here. So one more particular way. Again, I can have P here and S here. Again, between this P and this S. See how many boxes? 1, 2, 3, 4. So one more way. Like this, I can be writing how many? Just see this. Again, if P is here, S is here. Again, P is here, S is here. Again, P is here, S is here. Again, P is here, S is here. Don't get confused that, so at a time, how come P and S together? No, 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 no. This S is for that particular instant if P is here. Okay. So now, this since we have got only 12 objects, it ends here. Now just see how many such possibilities are there. 1, 2, just count P. 1, 2, 3, 4, 5, 6. I repeat, 1, 2, 3, 4, 5, 6, 7. Totally 7. So in place of again 1 plus 1 plus 1, I should write what? 7 ways. Because 1 added 7 times. Clear? Okay. Now again observe the question. They just said there are always 4 letters between P and S. They never said between P and S when I write always P should be in the left, S should be in the right. Then we should have 4 objects. They never said that. It can also happen that in between these 4 objects, I can have P here and then S here. That also there. That I will try to show below. Okay, so that there is no overlap. So it means if P is here, again 1, 2, 3, 4 box you leave, then S is here. Again, if P is here, S will be here. Again, if this P is here, S will be here. Again, if P is here, I write it below, S will be here. Okay. Again, if P is here, for this box, S is here. Again, if P is here, S will be here. Again, there is no overlap. It means what? This S, right, is for which? This P, first P, correct now? And again, if P is here, S is here. And there is no more box. That's it. Now just count again. Either P you count or S you count. How many are there? Let us suppose S you will count now. 1, 2, 3, 4. Okay. 5, 6, 7. No, sir, I want to count P only. Count 1, 2, 3, 4, 5, 6, 7. So again we have 7. Now see carefully. In between this what sign should be written? Plus fundamental principle of counting should be applied here, because at a time both is not going to happen. Either at once P will be at the left and then S will be followed, or P will be at the right then S will be followed. Okay. And this into it is multiplication. That's what I said. No, both are involved. So 7 plus 7 is 14 into this particular value. We have already got it is 18. Okay, 14 400. Good thing is you have got calculator use, so you can use calculator and then write the solution from here, or we'll compute that. Okay, 0. Now let us multiply. So let us rewrite this one as, okay, anyway calculator is allowed for you. So I'm just writing in A into B same as B into A. This will be easy to multiply. Come on. 4 multiply 12, 4 0 0, 4 0 0, 4 4s are 16, border 1, 4 4s are 16, 16 plus 1 is 17, 4 1s are 4 plus 1, 5, 8 into 4 will be 32, 4 1s are 4, 5, 6, 7, into, okay, again 1, multiply 2 are 0, you get 0, 4, 4, 1, 8, 1, so 0, then 6, 6, okay, 7, 8, 9, 10, 11, border 1, 5, 5, 10 it will be, borrow 1, 2, 3, 4, then 7, 7, 14, 15, and this. So in these many ways you can arrange. So how many ways? 2 crore 54 lakhs 1,600 ways we can do. Okay, make a note of this. Okay. Dear students, before taking up the next problem, one small concept. Okay, let us understand practically. Now, what can you see in my hand? Marker. Are these identical or different object? Identical means same. Okay, are they same or different? This you can see cap blue and here it is black. So very easily you can identify that these are two different markers. Now I have got two markers, nothing but two objects. In how many ways can I arrange them? One like this, other is like this. So how many ways? Two ways. One is this way, other is this way. Okay. So in this, as per your view, this is left, this is right, and now this is left and now this is right. So you can see arrangement is different if it is distinct object. So here I can say that if I have got n object and this n objects are if this n objects are distinct or what distinct, then number of ways of arranging is n factorial. For example, here we had two markers, 2 factorial is what? 2 only. Similarly for A, B, C, we have three different objects and all the three I want to arrange 3 factorial 6. I hope this is clear, which we already discussed. Now see other scenario. The other scenario is, yeah, now let me move this marker out. Now you see, what do you see? Okay, so these two are what? Yeah, identical. Correct, both are black. Now whether I keep like this, now for a while, see this, what's the location? You have seen the location, no? Now close your eyes. For a while, close your eyes. I will change the, I'll do the arrangement for this. Close your eyes. Now open. Okay, see from here, close your eyes. Now open. What you can see? Can you make out the difference? Surely no. Why? Those are identical objects. Or something like caps are looking different, so you may have a feeling that okay, forever, hold on. Yes, now see, I have got two. Yes, yeah, and camera also is looking identical only. Yes, perfect. So let's go ahead. See this? You can see two objects, right? Now close your, first observe the location, okay? Which is left, which is right. Now close your eyes. Okay, close your eyes. Now, see now. Is it changed or unchanged? You can't make out. Correct? Again, close your eyes. Now open. Is it changed or unchanged? Actually, now have not changed. But then also you cannot make out because both are what? Identical. So number of ways of arranging the identical objects is, if I take all together, I repeat, I want to arrange all the n identical objects, then the number of ways is only one, whatever is given to you. Why? Even if I do the rearrangement like this, we cannot make out because those are what? Identical objects. I hope this point is clear. So coming to n object, if it is distinct, that's number of ways of arranging. This will be number of ways of arrangement. Are what? N factorial ways. That's what I wrote here. This is for distinct. Let us suppose we have n identical objects. Identical objects. Then in how many ways can I arrange? It is only one way. If n identical objects is there, the number of ways of arrangement is only one way. Don't forget this, only one way. Now let us take this problem, and next problem is going to coincide with this point. Okay, they are saying second sub problem we are yet to complete, and second sub problem also came in model question paper number 2 for 3 marks. Okay, so in how many ways can the letter of the word permutation? Second sub problem we are going to go for permutations. Vowels are all together. Vowels should be together, so they should not be separated. First collect vowels. Which are the vowels here? A. I'll use other color. Both are. Fine. Let us go for this. Yeah. A. Find A. Then E. Let us go in order also. E. Then O, A, E. Okay, I is also there. Fine. I will write it here first. There's nothing like orderly you should write, but I just want to not miss anyone. Okay. A, E, I, O. O is also there. Okay, fine. Correct now. E is there. U, A, I, O. T is not the vowels. This should be always together. So what I will do, I will tie them. Why? When I arrange, it should not happen. No, one of them will be mischievous. So it might go here and there. So to avoid that mischievous thing, what I will do, I will tie them. Okay, I am tying them. Okay, I am tying them. Now let us denote this one as some one letter, let us suppose vowels, no, V. Okay, divided by V. Now see the letters, remainder. P is taken out, then R, then M, used out, T, after T again T, then NS. So 1, 2, 3, 4, 5, 6, 7, 7 plus 5, 12. Yes, and vowels all together is here and divided by V. Okay, they are together. Now count how many letters are there, how many objects are there. 1, 2, 3, 4, 5, 6, 7, 8. In which T is repeated twice. T is how many times? 2 times. Okay. Now number of ways of arranging such a way that all are together will be 8 objects. So 8 factorial. Okay. Divided by 2 factorial. This has taken care of only this PRMTTNSV. But what about this V? Nothing but this. They can get arranged among themselves. Now when I'm seeing this letters, which are those? A, E, I, O, U. I have 5 distinct objects. Number of ways of arranging all the 5 distinct objects. Number of ways of arranging all the 5 distinct objects will be in how many ways? 5 factorial ways. I hope this point is clear. So this is taking care of this. But what about V? We have got 5 objects and I have to arrange among themselves and all the 5, and they are not identical, they are distinct. Now we have to simplify. Come on, simplify. 8 factorial. Okay. 8 into 7 into 6, 5, 4, 3, 2, 1. Divided by 2 factors, 2 into 1. So I can say 2 1s are, 2 4s are here. And again 5 factorial is there. 5 into 4 into 3 into 2 into 1. Let's simplify here. See carefully. Okay, see this value we know it will be 120. Okay. Again the value from where to where? 5 into 4 into 3 into 2 is 120. So many times I have calculated, no, so I remember that value. But anyway, you can use calculator. Next is 4 into 7 into 6. 4 into 7 into 6. We have to multiply. Fine. Let us multiply. 7 4s are 7, 14, 21, 28. For this, I'll get 28. Correct now? Multiply by 6. 6, so 36, 42, 48. 6 to the 12. 12 plus 4 will be 16. And here, 12 into 2 and into here. 12 into 12 is how much? 144. And we have 2 zeros. Okay. Just you can multiply this. Let us write the final answer. Multiply this and get the answer. Okay. So the answer after multiplying this will be 2419 200 base. Don't forget calculator is allowed for you. Okay. And the same problem, because this the problem of 5 marker completed. The same problem has come in. Let I just see and let you know. Yeah. Okay, the same problem, I repeat, the same problem has also come in model question paper number 2. Question number is 35 and this has come for 3 marks. Only this part. Only this part. Okay. They have not as first, not third for 3 marker question in model question paper number 2. Okay. And remember this logic, we are going to use it for the upcoming problem. Kindly make a note. Yes, dear students, now let us move on to the next 3-marker question on permutations. It's a model question number 3, question number 33, and it's a 3-marker question. And it's going to go with that vowels problems, which we just finished from the problem permutations. Okay, before I go ahead, understand this. First point, if we have n distinct object and I want to arrange all the n distinct object, it is n factorial ways. Okay, n factorial ways. Okay, so can I use this? Let us suppose that I have n identical objects. I want to arrange all. It is only one way. Now they are saying in how many of the distinct permutations. As soon as you see permutations, nothing but what arrangement of the letters in Mississippi. In what Mississippi do the 4 I's not come together? They should not be together. Solution. See, whatever that formula we have got for permutation for identical, that give all the possible arrangement together, without together, okay, everything. Now we want not together. So what we will do, see carefully. Just analyze in the form of a set. This contains all the arrangement of the word Mississippi. The I's can be together. Yes, also you can see 2 S are 4 S are there. They can be together. I is also there. They can be together also, not together also. Mix, all mix are there. All arrangement. This stands for all arrangement. Okay. Or they can say than saying all, no, total arrangement. Total arrangement. Total arrangement. But I can also find one particular arrangement here where all 4 I's are together. I have all the 4 I's present and all that arrangement is present here. Okay, all 4 I's together. Now what I want to write that 4 I's also for you, that will be visible. So here I have got all those arrangement in which all 4 I's are together. Now it means this part will be what? Those arrangement where all the 4 I's are not together. So I want here all 4 I's not together. Not together. So how to get that? It's very simple. See, from the entire arrangement, total arrangement, subtract all the 4 I's together. As soon as I subtract, as soon as I remove this, I'll get what? All the 4 I's not together. So we are going to apply this logic. So total, so we want all 4 I's not together. Correct? No, not together is same as, I think the ink is not so dark. Oh. Is same as total arrangement minus all 4 I's together. All 4 I's together. So that's fine. Total arrangement in the word Mississippi. Let us take that Mississippi. Yeah, here only. Mississippi. When you write these words again, recheck. Have you written correctly? Yes. Now all the arrangement. How many letters are there here? Check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 factorial total arrangement we are talking about, in which some of the letters are repeated. I, you see how many times are there? 1, 2, 3, 4. 4. So I is there 4 times. Any other? Yes, you see 1, 2, 3, 4. So yes is also there how many times? 4 times. Next, what is there? P. That's also 2 times. Any other is there? Any other? Repeated? No. So total is 11 divided by I is there 4 times, S is there 4 times, P is there 2 times. So divided by those factorials. And understand now, in permutations, when they said vowels together, after we did this, we also arranged all those 5 vowels A, E, I, O, U because they were distinct. So it is n factorial ways. But here, when I want to arrange, okay, this part is done. Okay, this part is done. So nothing to talk about for identical. I was talking about this. I repeat, Naseer, retake from here. So this 2 factorial, yes, after this, you cut that part. Okay, now come for all 4 i's together. All 4 i's together. So again, for this part, okay, all 4 i's together, let us rewrite this m, yes, 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 p, p, and here let one I1, where this I1 stands for all the 4 i's. So I want to arrange all the 4 i's and I'm going to tie them up by a rope. Same logic of vowels problem. Okay, different color I could have used. They are together. Okay, so now count how many are there? 1, 2, 3, 4, 5, 6, 7, 8. Totally 8 factorial divided by, in this yes is there how many times? 4 times. P is there how many times? 2 times. Okay, so now the answer will be 4 factorial here and into 2 factorial. Now comes the difference. In the vowels problem, since when we want to arrange them together, we had 5 distinct objects, that is A, E, I, O, U, that can be arranged in n factorial ways. So since we had 5 objects total for vowels, A, E, I, O, U, so 5 factorial ways. But here, since we have 4 objects, but all are what? Identical. Number of ways of arranging identical objects are what? Only one way. So into 1 factorial. Okay, now let us simplify this. Let us use calculator for this. Okay, fine. Let us complete from here. So we can write from here. Say this 11 into 10 into 9. Is it recording? Yes. 8. Double check is always required. It should not happen now. I'm explaining, but it's not recorded. Divide by 4 factorial. Here we have 4 factorial. So 1 4 factorial will get cancelled here. Then here 4 factorial is what? 4 into 3 into 2 into 1. Then 2 factorial is what? 2 into 1. Okay, minus. Then again this 8 factorial into 1 is 8 factorial. What is 8 factorial? 8 into 7 into 6 into 5 into 4 factorial divided by 4 factorial. Then 2 into 1. So 4 factorial also gone. 2 1s are 2 3s are. So here also see this 4 2s are 8. Then 3 2s are 6. So write down the remaining. 11 into 10 is 110 into 9 into 7 into 2 is 14 into 5. Oh, divide by 2. No, this 2 and this will get cancelled. So I can just say 7 into 1 is 7 only. Okay, no? I didn't cancel this 2. Now I have done. Then here 8 into minus of 8 into 7 into 3 will be 21 into 5. Basic things we can do whatever way we want. Okay. Now let us use calculator for this. Into 9 into 7 into 5. This will give us 34650 minus 8 into 21 into 5, 840. If we subtract this, we are getting 34650. 33810 ways. So these many ways we can arrange. Okay. So this was only the concept. Okay, so fine. With this, we are completed all the permutations concept and the problem. Now we'll go for combinations. Make a note of this. Dear students, having understood permutations and the problems completed from model papers, now it is time for the next concept, the last concept, that is combinations. Now let us try to understand in detail what is combinations. See, when I say combinations, it is selection of objects. I repeat, it is selection of objects taken sum, S-O-M-E, sum, or all at a time. Whereas permutation was arrangement. Coming to combination, it is what? The selection of objects. Now let us try to understand in detail. Okay, I would like to quote the same example ABC. So if I take A, B and C and I want to select this time, not arrange, select, and here in select, no, I want two at a time. Select two at a time. That's what we said. No, selection can be all or some. So here I got three objects. I'm taking only two. So when I want to select, fix A, solution A, and I want two at a time. So A I can select with B, or A I can select with C also. With respect to A, all done. Now take B. B I can select with A. C, that is already taken here. It means that BA and AB both are same. In permutation, it is different because it is arrangement. Here in combination, they are same. Similarly, B to C. Now with respect to B, both over. Now C. C to A. C to A is same as A to C. Then C to B. This will be the different ways of selecting. So three ways of selection. So one thing is very clear that AB and BA, AC and CA, BC and CB are same. In selection, order is not important. In selection, what is not important? Order is not important. Let us try to understand with the help of an example, real world example. So again, cricket I would like to quote, the one which I quote in sets, because the trend present in India, no, cricket, no, high fever of cricket. Now, listen carefully. Whenever Indian cricket team is announced for playing with some other international cricket team, first they are going to announce the team. When they are going to announce the team, they announce the cricket team of 16 squads. No, when they announce, not the player name. For example, let us suppose Kohli, Rohit. Whether they mention the name of the Rohit or Gill at the beginning or at the end or in middle of the 16 players, they are selected. Here order will not be important. Only thing is that name should be announced that he is selected. So when they are announcing the team for playing the cricket, okay, that is selection, nothing but combination. Now the team arrives on the ground and only 11 should play. Captain goes for the toss, and let us suppose he can bat now. Means our team is going for batting. Then order comes. In the playing 11, if the first name is Kohli, second name is Rohit, it means what? Kohli is going to face the first ball. Whereas Rohit will be on the non-striker end. Now here comes the order. So Virat Kohli name first, then followed by Rohit. It means Rohit is a non-striker end and Kohli is the striker end. He is going to strike the ball. Similarly, other way around. First name is Rohit and second name is Kohli. Then Rohit is going to face the ball and Kohli will be in non-striker end. This is permutations. I hope this logic is clear. So in permutation, order is important. In combination, order is not important. So having this logic, let us try to understand, do we have any formula for this? Yes, we have. Let us go for one by one here. The formula will be NCR is equal to n factorial divided by n minus r factorial into r factorial, where n is greater or equal to r. Again, here stand for total number of distinct objects. Total number of distinct object. Distinct means different objects, and now stand for how many objects we are taking into consideration. And this formula I can also write, this is also going to hold true for 0 less or equal to r less or equal to n. So always r should be lying between 0 to n. Now from here some of the important deduction. First, can we get this result by using this formula? Let's try to go ahead. Here total objects are how many? 3. So n is equal to 3. How many objects I wanted to select? 2. So r is equal to 2. See, I use the word here. The word I said select, not arrange. So now NCR is equal to n factorial divided by n minus r factorial into r factorial. So n is 3. See, r is 2. Put here is equal to 3 factorial divided by 3 minus 2 factorial, then 2 factorial. 3 minus 2 is 1. Then 3 for what? 3 into 2 factorial. So the same 2 factorial, I'm adding it here, and both can get cancelled. 3 by 1 factorial is what? 3 by 1. 3 by 1 is what? 3 itself. That's what we got. 3 ways. Okay. Now let us have some directions from the formula. Observe carefully. See this part. Have you seen this part in black box? What is this? It is NPR divided by r factorial in denominator as it is. Very, very important relation. What? From, see, let us suppose I got combination. Okay. Or like I would like to go like this. I got permutation, but I want what? Combination. For that, divide by r factorial, you will get selection. Similarly, if I cross multiply this, I will have NPR is equal to NCR into r factorial. Nothing but I got already combination. I want to go for arrangement. So just multiply by r factorial. For example, here I got the selection. I want arrangement. R is what? 2. So into 2 factorial will be how much? 2. 2 into 3 will be 6. That's what we know. Already we have seen that if these are not equal, 1, 2, 3, 4, 5, 6 will be the 6 arrangement. Next, having some more direction. See this formula. If r is equal to 0, nothing but I don't want to select any of the object. See, when I say I don't want to select any one of the object, it also means that I'm not selecting any object, no? Correct? So how many ways we can ignore the object? Only one way. Don't select them. Reject them. So one way. One should be the answer. So just see, can we get this? Put here. I'll take this as 1. If I put in equation number 1, we get NC0 is equal to n factorial divided by n minus 0 factorial, then 0 factorial here. So n minus 0 is n with factorial. 0 is what? 1. Then n factorial. Both will get cancelled. Answer will be NC0 is equal to 1. Similarly, so number of ways of rejecting all the objects are only one ways. Now, let us suppose I want to set all the objects. I've got 100 objects. I want to set all. In how many ways I can do? One way. Take all. Select all. So, yeah, R is equal to n. Put here. What we will get? Substitute here. I'll get NCn is equal to n factorial divided by n minus n factorial into n factorial. Something will get cancelled. N factorial gone. So, what is remaining? 1 divided by n minus n is 0 with a factorial. What is 0 factorial? 1. 1 by 1 is what? 1. Therefore, NCn is 1. This is also standard result to remember. One more point you see. What if r is equal to 1? Nothing but number of ways of selecting 1 out of n object will be what? N ways. I can set any one of them. So out of 5, I can set first object or second object or third or fourth or fifth. So 5 ways I have got. For 5 objects, correct? No. So if I put here, this is our point number 4. Put in 1. See carefully. NC1 is equal to n factorial divided by n minus 1 factorial into 1 factorial. I can write numerator n factorial as n into n minus 1 factorial divided by n minus 1 factorial as it is into 1 is same. Into this will be same. 1 5 what 1. Okay, right. Now something will get cancelled. This n by 1 will be what? N. Therefore, NC1 is n. Okay. First, make a note of this. Okay. Dear students, let us move on to some other concepts on combinations. And I am covering, as I said, each and every concept because this will be helpful for the next chapter, probability. Okay, which I'm going to take after this. Now coming to combinations. Next concept, I think 1, 2, I just forgot the numbering, what I gave, maybe 3, I think 3 or 4, whatever number. Next point. Okay, I think 1, 2, 3, fine, some 3 or 4, 1, 2, I think this is 5, whatever. Okay, the numbering you can just see. Now, if that is 3, this is 4. If that is 4, this is 5. Okay, nothing else. Now, just move on to next. See, NCR is same as NCN minus R. Let us first try to prove this and then we'll comment. These both are same. I have to prove it. For this, first coming to the proof of this is a very useful result. See, if I write the left hand side, NCR is the formula we know, n factorial divided by n minus r factorial into r factorial, where 0 is less or equal to r, less or equal to n. Now, if I take right hand side and apply this formula, NC n minus r. So, in place of r, it is n minus r. Substitute here wherever r is there, n minus r. So, n remains n. So, n factorial divided by n minus, in place of this r, we have n minus r. Be careful, many will not give bracket. This minus for the entire term. So, in place of r, we have n minus r. So, bracket should be given. And to avoid confusion, I am giving a rectangle bracket for this whole factorial. And again, in place of r, what it is? Again, I am saying in place of r, what it is? N minus r. Now, what we will get? N factorial, simply for the denominator here, just see carefully, I'll get it here. N minus to plus is minus, n here, then minus to minus is plus r. Okay, let us give a rectangle bracket only, whole factorial, this will get cancelled, so I'll get r factorial. So r factorial, then this is n minus r factorial. See carefully, this and this both are same. N factorial, this r factorial is here, and n minus r factorial is here. Nothing but what? NCR. Okay, what is the meaning of this? We have proved. But what is the meaning of this? This I will take as, okay, fine. From formula we have got left is equal to r. Left is equal to right. NCR is equal to NCN minus r. What is the meaning of this? This implies number of ways of selecting r objects out of n is same as rejecting n minus r objects. For example, I've got 5 objects. Out of 5, when I'm saying I'm selecting 2 objects, it is same as out of 5. See, out of 5, I selected 2 objects. So 5 minus 2, 3. So it means I rejected 3 objects. So 5, C3, both are same. So you can just see computation wise also. So again, by using this formula, 5C2, it is 5 factorial divided by, in place of r, we have 2. So we are going to have 5 minus 2, then 2 factorial. So I'm talking about 5C2 computation here. So it is 5 factorial. See, 5 factorial same as 5 into 4 into 3 factorial. Stop by 5 minus 2 is 3 factorial. So I can cancel this 2. Then 2 factorial is what? 2 into 1. 2 ones are 2 twos are. So 5 twos are 10 we got. Come to 5C3. 5C3 will be again 5 factorial. In place of r we have 3. So put everywhere where here wherever r is there 3. So divided by 5 minus 3 factorial into 3 factorial. 5 minus 3 in denominator is 2 factorial. Then 5 factorial is what? 5 into 4 into 3 factorial. Here also 3 factorial. So 3 factorial by 3 factorial will get cancelled here, and then 5 into 4 is 20 divided by, what is 2 factorial? 2 into 1. 2 ones are 2 tens are. So answer is 10. We got the same. That's what it is same. So let's comment here. This says here selection of r objects out of n objects is same as rejecting n minus r objects. N minus r objects. Okay. Now having this, let us move on to one more result. See carefully and pay attention. This will be required for our 1 marker question. The next result is, if NCA is equal to NCB, then what can we conclude? There are two things to conclude. What? Solution. There are two things to be concluded. What? It can happen that since equal is a total number of objects are same, it can happen that A and B both are same. That's the first choice. But it may not happen like this. You see, we got the value of these two to be what? 10 each. But 2 and 3 are not equal. Then what's the case? So let us consider NCA is equal to NCB. It is selection of out of n A object is selected, out of n B object is selected. This is same as out of n minus B object rejected. Now if I equate this to n, means A is equal to n minus B, solve for n, transpose B here, A plus B is equal to n, or n is equal to A plus B. That's what you can see here also, no? 2 and 3 are not same, nothing but in place of A and B, we have 2 and 3. 2 plus 3, 5. That is 5 here. Okay. So whenever we have NCA is equal to NCB, there can be two things. Either A is equal to B or N is equal to sum of A and B. Okay. Make a note of this. Dear students, let us move on to the next derivation, a small derivation. It is step number 6 in NCERT numbering. The result says sum of NCR minus 1 plus NCR is N plus C, is equal to N plus 1 CR. Okay, let us try to prove this result. Now first let us prove this. Okay, now coming to the proof of this, see left hand side, if you see, we have NCR minus 1 plus NCR, combination question. So recall what is combination formula. We know that NCR is n factorial divided by n minus r factorial into r factorial. So for this directly I can use the formula. Whereas coming to this, in place of r we have r minus 1, n remains n, correct? No. So wherever we have, for this one, wherever we have r, we should replace by r minus 1 here. So n factorial as it is, there is no change for that, divided by n minus, in place of r, r minus 1. Again bracket is mandatory. If you don't give a bracket, it means minus only for r but not for minus 1. So bracket is mandatory. Okay. Then whole bracket, the factorial. Then in place of r it is r minus 1 factorial. Now simplify. See carefully this part. Can we simplify? N minus plus is minus r, minus to minus is plus 1, the whole factorial, correct now? So let us write in next line what we are getting. N factorial divided by, this will be n plus 1 minus r, writing in order. Okay, then r minus 1 factorial plus, here it is n factorial divided by n minus r factorial. Let us r be looking proper for a while. Yeah, then r factorial. Okay, is this fine? Now see carefully. We should try to minimize our factorial. Numerator no problem. Denominator, you see, here we have n plus 1 minus r factorial. Here we have n minus r factorial. N minus r factorial. Among the two, who is larger? N plus 1 minus r is larger than, compared to this, because you can see n minus r, n minus r. Here plus 1 is there. So one term is more compared to here. Correct? No? So this will be larger in terms of number. It is larger. If it is, let us suppose this is 5, this will be 6 because plus 1 is there. So this is larger. So we can rewrite this one to be n plus 1 minus r as it is into n minus r factorial. Sir, how? Simple. 5 factorial is same as 5 into 4 factorial, and I can stop. 5 is this entire, I mean to say this is 5 factorial. Okay, now see, now this is 5 and this is 4, 1 less than. Okay, now this one, okay, still this one I will retain. Now plus n factorial divided by n minus r factorial. Now see, r factorial is there here. Among this r factorial and r minus 1 factorial, r factorial is larger. Again, using the same logic, I can write r factorial as r into r minus 1 factorial. Job done. Now try to take common. Why we did this? So that we can take something common. See what's common here? N factorial common. Then what next? N minus r factorial common. Then what next? R minus 1 factorial common. Okay. What next? Nothing is common in, nothing is remaining in numerator. So 1. And whichever we have taken common, I have given a blue line. Okay. So only this is pending. And here 1 by r is pending. So what is remaining? N factorial divided by n minus r factorial into r minus 1 factorial, and coming to this, what is LCM of fraction? You can see plus sign is there. So LCM I have to take LCM of n plus 1 minus r, and r will be product of both n plus 1 minus r into r. Now what we have to do? Divide this term by this. N plus 1 minus r will get cancelled. Remaining is r. R into 1 is r, plus this divide by this, r will get cancelled. N plus 1 minus r into 1 will be n plus 1 minus r. Now simplify. When I simplify, can you see plus r and minus r will get cancelled? So remaining is n factorial into n plus 1 divided by, see carefully now, see carefully, I am rearranging, same term, n minus r, and here n plus 1 minus r. This two term I am arranging together. Then, okay, this two term, you can just think like terms are taken together. Now, again, same logic. I am going from right to left. If I have 4 factorial into 5, nothing but it is what? 5 factorial. Nothing but these two are consecutive terms. And factorial is there for the term which is just less than this. Same thing, is it not happening everywhere? See carefully. See carefully. Here it is n is 4 and n plus 1. So the numerator becomes n plus 1 factorial. Similarly, you see this term. Again, this is like 4 and this is just 1 more than 4, nothing but 5. So what will be that? N plus 1 minus r factorial. Similarly for this two also. This is 4 and then r, nothing but just more than that, 1. Now see this one, compare with the formula. This formula, yeah. See, n then r. The difference of this is here, correct? No, difference of this and this is here. See this carefully. N plus 1 and r. Difference of these two is here, correct? No, so exactly difference of these two is here. So it's exactly obeying this. So I can write right to left. So I'll get what? N plus 1 C R. That is our right hand side. Yes. Okay. With this all concepts are done, we start with the problems of model question paper. Make a note. Okay. Dear students, now let us move on to the problems from model question paper on combinations. From model question paper number 1, a 1 marker question, fill in the blanks, and the same question has come in model question paper number 3 with question number 19. Okay, so it's repeated question. So question says if 15C3R 15C3R is equal to 15C R plus 1. Retake. Dear students, let us move on to model question paper problem. This problem has come both in 18, that is this has come in model question paper number 1 and 3, and I have given the question numberings. Okay, fill in the blanks question. So they are saying that if 15C3R is equal to 15C3 plus R, then find the value of R. So as we discussed one concept that if NCA is equal to NCB, this can happen that either A is equal to B, which you can see they are not same. Then what should happen? N should be equal to A plus B. Or it is, okay? N should be equal to A plus B. So since it is not same, so this is your A. This entire thing is your B. And in place of N we have 15. So we are going to have N is equal to A plus B. What is N value? 15. What is A value? 3R. What is B value? 3 plus R. Solve for R. So 3 I can transpose here. So I'll get 15 minus 3 is equal to 3R plus R will be 4R. Okay. So this is minus 3. So what is 15 minus 3? 12 is equal to 4R. 4 ones are 4 3s are. Therefore R is equal to 3. R is equal to 3. So our value is 3. So how to cross check the values are correct or not? Very simple. Put in the question. R is equal to 3. 15. See, 3 into 3 will be 9. Again here 15C. 3 plus 3 is 6. So we know that if we add this 2, we should get N. So 9 plus 6, how much? 15. Yeah, that's your N value. Yes, it's correct. Come to this. In how many ways can a team of 3 boys and 3 girls be selected? The word selected saying that it is some combination. The word arrangement is not there. Previous all problem 2-3 marks question on permutations. Either the word permute was there, permutation or arrangement. But here it is selected. Of what? We have to select 3 boys and 3 girls to be selected from 3 boys and 3 girls. Solution. See carefully. First, out of 5 boys, we want only 3 boys to be selected. So 5C3. Out of 5 boys, 3 boys are selected. Next, out of 4 girls, we have to select only 3 girls. So out of 4, 3 girls are selected. That you will write in statement what I just said. Selection of 3 boys out of 5 is 5C3 ways. Selection of 3 girls out of 4 girls is 4C3 ways. Then by fundamental principle of counting, we are going to multiply. Why? Both is going to occur following each other. You know? As soon as this is occurring, this will also occur. Now compute from here. By using the formula, what is NCR? It is N factorial divided by N minus R factorial into R factorial, where N is greater than or equal to R. Correct now? So in place of N we have 5, in place of R we have 3, correct? Substitute here. 5 factorial divided by 5 minus 3 factorial into 3 factorial into, this is N and this is R. Substitute again. 4 factorial divided by 4 minus 3 factorial into 3 factorial. How much is 4? Means 5 minus 3, 2. And here it is 3 factorial. Correct now? So 2 will like factorial here. 3 factorial. So I can write 5 factorial as 5 into 4 into 3 factorial. So that this 3 factorial will get cancelled. Oh, same color there. Okay, fine. 3 factorial get cancelled. Next step. Into 4 factorial, same as 4 into 3 factorial divided by 4 minus 3 is 1, and here 3 factorial. So easily we can see 3 factorial will get cancelled. Now here also 5 into 4 divided by 2 factorial is 2 into 1. Then here 4. So easily 2 1s are 2 2s are 5 2s are 10. 10 into 4, 40 ways. 40 ways we can select them. Okay. So this is for 2 marks. And this is for anyway 1 mark. Fill in the blanks question. Kindly make a note. Yes, dear students, let us move on to the next question paper problem, model question paper number 2. It's a match the following and it's a 1 marker question. Oh, mic. Naseer, delete the interaction part of this. Light was not on, mic was not there. Okay. Yes, dear students, let us move on to the next model question paper number 2. 1 marker question. They have given us a match the following, but it's a MCQ based only. But here we have to match list A, list 1, list 2 is given, and we have to just choose the correct among this. Okay, let us move ahead. Now, one by one, we have to compute. See, coming to this, we already know that from the result, what is coming to first one? 5C0. Already have given the result, we have proved it. NC0 is always 1. So whenever R is 0, irrespective of whatever n is here, it's always what? 1. So here it is 0, so always the value is what? 1. So this is matching with third. Okay, so A is matching with third sub problem, means third in this B. 5P2. See, if you are okay, no, we can avoid the formula and get the answer. How? See carefully. Without formula, we can solve. What's the number here? 5. What's the number here? 2. So start from 5 less or equal to 5, but this will decide consecutive number. Here it is 2. So answer is 5. Then less than 5. Next number less than 5 is 4. Stop. Why stop? 2 is there. So answer is 5 into 4, 20. Let us take some problem to make you clear. If I give you 5P4, so what's the number here? 5. And what's the number here? 4. Start from 5, but you have to have 4 consecutive numbers less or equal to 5. So 5, then 4, then 3, then 2, multiply 120. Okay. Similarly, if I have got 5P3, why only 5? Come on, let's take some other number. 7P3. Okay. So 7 here and 3. So start with 7 less or equal to 7. 3 consecutive numbers starting from 7. So 7, then 6, then 5. So what's the answer? 6 for the 30, 30, 7 to 21, 210. Actually, even if you go with the formula also, you see 7 factorial divided by 7 minus 3 is how much? 4 factorial. So when you simplify 7 into 6 into 5 into 4 factorial, 4 factorial get cancelled, get back the same. Okay. So 5P2 is matching with this. So this is going with second part. Coming to C, 5C2. Again for this also, you can avoid formula. See carefully, same logic. 5 is there. Don't forget here in the formula of NCR, divided by R factorial, one extra term is there. So 5, again same logic, 2 is there. So 2 consecutive number divided by whatever number is there, that is 2 factorial, you should divide. Okay. So 5 into 4 divided by 2 into 1, 2 1s are 2 2s are, 5 2s are 10. So 10. This is going with this. It is second sub problem. First. So 5C0, we got 1. Once last cross check before ticking the option. Okay. So it should go as 3 1 2. 3 1 2. 3 1 2. Yeah, option D is correct. Correct now? 3 1 2. Okay, for this to be still more clear, if you want, you can take one more. 5C, let us suppose 4. Okay, you can let us 5 into 4 into 3 into 2 divided by what? 4 factorial. Nothing but 4 into 3 into 2. This will get cancelled. I'll get what? 5. But for this, by using the formula, NCR is equal to NCN minus R. Whenever this is a bit larger, you can use this formula and see this one says difference of these two. Correct? No? You can see this. This is what? Difference of these two. So if you take the difference of these two, what you will get? 5C1. What is NC1? N itself. So 5C1 is 5. Directly you can get. Okay? Fine. Make a note of this. Now we'll start with 5 marker question on combinations. Make a note. Okay. Yes, dear students, let us move on to our next 5 marker. I mean to say the first 5 marker question on combination, but for permutations, we have already finished 1 5 marker. Okay. So model question paper number 2 and 3 have got 5 marker problems on combination, which is the usual trend. Okay. Now let us go for the problem. Question says a group. Question number 41 for 5 marks. A group consists of 7 boys and 5 girls. Find the number of ways in which a team of 5 members can be selected so as to have at least one boy and one girl. Before I go ahead with the problem, no, students have got confusion with the word at least. Let us first clarify this. See, whenever you see the word at least, mathematical meaning should be, you should remember, greater than or equal to. And whenever you see the word at most, the symbol is less or equal to, meaning of that is less or equal to. Now the question will come, sir, greater than or equal to, less or equal to, which number? Which number? That will be specified in the question. Here they said at least one boy, one girl. Okay, so they specify in the question. Now, again, if you have a problem, sir, how to remember greater than and how to remember less than, already have said, no, in our other videos. So greater than, less than, spelling of less than, L-E-S, okay, T-H-A-N, than. This is same as this. As soon it is less than or equal to, equality also will come. Okay, for greater than, how to remember? Very simple, G-R-E-A-T-E-R, this symbol, greater than. Okay, fine. Now let's move on. Let us have in the form of a table. If we go with the table, now things will be very clear and you can avoid writing the description. Now, see carefully. Now, in the question we have got boys and girls, correct? No. So, boys. How many boys are there in total? Let us mention here 7. How many girls are there in total? 5. So we have first mentioned total number of boys and total number of girls. And now we have to select, right? Now while selecting, let us have here number of ways of selection. Number of ways. Okay. Now they have used, they want a member of 5 members. Not beyond that, 5 members. Let us have it here. Next. Selected word is there, so combination, no confusion that it's a permutation because selected word came. To have at least one boy and one girl. So boy should be 1 and 1 girl. But such a way that, now see, either you fix for boys or girls. Now when I fix for boy, I should have those number of girls here such that if I add 1 with that, I should go with the number of members, that is 5. Okay. So 1 is here. Which number should I write it here? If I add, I'll get 5, 4. Okay, so now see carefully how I'm going to write this. See carefully. Out of 7 boys, 1 boy is selected. So 7C1. Then out of 5 girls, 1 girl is selected. So 5C4. And since this can happen one after the other, so it is multiplication. Nothing but fundamental principle of counting of multiplication is used here. Next, we will compute this. First, let us write all the things. Now, increment. Why increment? Why not decrement? See the word here. What they gave at least. So it means this says greater than or equal to how many? 1 boy. Similarly for girls also. For girls also, greater or equal to what? 1 girl. Okay. For both it is given greater than or equal to. Let's give some space. Nothing wrong. Okay. So minimum 1 boy, 1 girl should be there. Now if I take 2 boys, then how many girls should be taken here so that I have 5 members? Surely what? 3, because 2 plus 3 is 5. Next, if I take now 3 boys, now how many girls here? 2. Why? 3 plus 2 will be 5. Yes. And this, what I'm writing, is obeying that it should be more than or equal to 1 girl. Yes, all these 3 are more than or equal to 1 girl. Condition is specified. It is obeying. Now if I take 4 boys, 7 boys are there. Yeah, 4 boys I can take. Now which number should I write here? If I add with 4, I will get 5 members. It should be what? 1. 4 plus 1, 5. No problem. Now you see, I have 7 boys. If I write 5 boys, since I want a member, total members to be only 5, I should write here 0 girls. Nothing but not even a single girl should be selected. But if I write 0 here, problem is they said minimum 1 girl should be there, greater or equal to 1 girl. So this is going against the question, so I have to stop. I have to stop. So you understood when to stop. You cannot write 5, 6, 7 because number of boys are 7. No, you have to meet the condition both. Okay. Now I hope we can go ahead. Now see from here, out of 7 boys, 2 boys are taken. So 7C2 into out of 5 girls, 3 girls are taken. So 5C3. Then out of 7 boys, 3 boys are taken. So 7C3. Why into? Why? Both are happening. Okay, one after the other. Out of 5 girls, 2 girls can be taken. So 5C2. Then out of 7, it can be 4 boys. Then out of 5 girls, 1 girl. Now we have to simplify. Now comes combination. 7C1. See, we already know that what is NC1? It is N. Because of this result, 7C1 is direct. It is 7. So let's substitute here. We also know that NCR is same as NCN minus R. So 5C4, I can write as difference of this will be what? 5C1. So when it is 5C1, whenever it is 1, whatever number is the same number here. So 1 is there, so I'll get 5. So see, into 5. What is 7 5s are? 35. So this, whatever the way we are taking, out of 7 boys select 1 boy, and out of 5 girls select 4 girls, this number of way will be 35 in this. Now come to 7C2. Let us take 7C2. 7C2. This will be again either formula or that logic. Let us go for that logic. Let us learn that. 7 is there here, 2 is there here. So what I get? 7, then 6, right? Divided by 6. 2 consecutive number because 2 is there here. Less or equal to 7, including 7. So 7 into 6. And here we have a 2. So divided by 2 factorial, which is 2 into 1. So 2 1s are, 2 3s are, 7 3s are 21. 7 3s are 21. So as soon you get, write it first. Into 5C3 what? Is it not 5C3 is same as? Okay, 5C2. So anyway, we complete 5C3 is 5 into 3 is there. So 4 into 3. 4, let us write properly. Divided by 3 into 2 into 1. Divided by factorial. Okay, directly we can write. So 3 gone. 2 1s are, 2 2s are, 5 2s are 10. So 5 2s are 10. So 21 into 10 is 210. Now 7C3. 7C3. Here 7 and 3. Start with 7. Less or equal to 3 consecutive numbers starting from 7. So 7, then 6, then 5. Divided by 3 into 2 into 1. 3 2s are 6 gone. 7 5s are 35. And coming to 5C2. Is it not by using this result? NCR is same as NCN minus R. I can always have a subtraction. So 5C, if I subtract this, I get 5C. 5 minus 3 is 2. So 5C2 is how much? 10. 10 into 35 is 350. Now 7C4. 7C4 is again here. Is same as. Subtract this 2. 7 minus 3 is 4. When you are using this logic, you should quote this reason. Okay. So it is 35. And 5C1. Yes. By using NC1 is N. So 5C1 will be 5. So multiply 5 5s are 25, 5 3s are 15, 16, 17. Now understand. Here we multiplied by using fundamental principle of counting under multiplication because one is following the other. But now at a time when I'm selecting a member of 5, no, as soon as I have taken from 7 boys, 1 boy, I cannot go for this. I think but this 2 cannot happen. Okay, simultaneously, one after the other. That's the reason we are going to total this. Now what we are doing here, it is fundamental principle of counting of addition. That's what I said. It's not quoted in NCERT, but we are using that concept. So come on, add this 5 marker easily. We can get 5 plus 5, 10, borrow 1, 3 plus 1, 4, 4 plus 1, 5, 5 plus 5, 10. Then here 17, again borrow 1 here, 3, 6, 7. 3, yeah, 6, 7. 770 ways. These many ways we can go for the problem. Kindly make a note of this. Okay. Okay. Yes, dear students, we are with the last problem from this chapter for 5 marks from combinations. This is from model question paper number 3. 41st question, 5 marker. Question says a committee. Oh, a committee. Spelling is wrong. Okay, a committee Okay, fine. A committee of 7 has to be formed from 9 boys and 4 girls. In how many ways can this be done when the committee consists of? There are 3 sub-problems. Let us go one by one. So first, try to understand the data. As per the question, we want a committee of 7. Okay, 7. So committee of how many? 7, not beyond than 7. Okay, and we have how many boys? 9 boys and 4 girls. So 9 boys and 4 girls. Now in how many ways this can be done? When the committee consists of exactly 3 girls. First sub problem, exactly 3 girls. So out of 4 girls, we should select only 3 girls. Okay, and out of 9 boys, now see exactly 3 girls. They are not commented anything about the boys in this. But don't forget, we want a committee of 7. So I have totally 9 boys. Now out of 7 in the committee, already 3 girls are selected. So 7 minus 3 is how much? 4. So only 4 boys should be taken. Don't think no question is incomplete. As soon girls, exactly 3 girls we have selected, then since we want a committee of 7, so 7 minus 3 will be 4. So 4 boys. So out of 9 boys, 4 boys are selected and we can multiply. Now from here we know that NC1, okay, NCR is same as NCN minus R. So from this I can write difference of this, correct? No, difference of this N minus R. This will be 4C1 and this will be 9. Since I got 4, start from 9, less or equal to 9, 4 consecutive numbers. So 9 into 8 into 7 into 6 divided by 4 factorial. 4 factorial, nothing but 4 into 3 into 2 into 1. Now, what is NC1? N itself. So 4C1, 4. Whatever N is the same. So 4 into. Now let us try to simplify some of the terms. Can you see very clearly? 4 into 2, 8. 3 ones are 3, 2s are. So now from here, let us simplify. 9 into 7 into 2. Okay, let's write it here. Can we complete here? Okay. 4. 7 9s are how much? 63 into 2. So multiply now. 4 as it is. 2 3s are 6. 2 6s are 12. Correct now. Again multiply 4. 4 6s are 24. Borrow 2. 4 2s are 9 10. Borrow 1. 4 1s are 4 5. So 5 0 4 ways this can be done. Anyway, calculator is allowed. You can use calculator for this. Now come to second sub problem. At least 3 girls. Let us have a table again. That will be easy for us to analyze. At least 3 girls. So here again, since the condition is on girls, no, we'll write first girls. That will be easy for us to analyze. Girls. How many girls are there? Totally 4 girls. How many boys are there? 9 boys. So 4 girls and total number of boys in the question given 9. And here we are going to find number of ways of selecting them. Now let us form a table, but before that 3 girls, correct now? So see carefully. If I take 3 girls, at least they have given, no? At least, what's the meaning of the word at least? Recall. Greater than or equal to 3. Minimum 3 girls should be there. Okay. Now when 3 girls are taken, how many boys should be taken? Committee of how much? How many? Committee of how many? 7. So same, no, whatever just now we got, same it is. Yeah, 3 girls, that's what 3, no, same whatever we got here, 4 boys. Then this will be out of, let us have a table. Now see, out of 4, 3 girls are selected, and out of 9, 4 girls, so 4 boys are selected, and this we have already computed, so no need again compute. This value we got 504. Let us just copy down, no need to again recompute, but it is already done in the problem. Now increase number of girls. Why, sir? Get are equal to 3. So next number 4. 4 in number girls. If you take 4 girls, if you select 4 girls, since we want a committee of how many? 7. Therefore, number of boys should be here 3. So that 4 plus 3 is what? 7. So out of 4, 4 girls are selected. Then into out of 9 boys, 3 boys are selected. Now let us compute this. What is 4C4? It is 1. Reason NCN is 1. Next, what is 9C3? It is 9. See here, 9 and here is 3. So 3 consecutive number less or equal to 9. So 9 into 8 into 7 divided by 3 factorial. 3 into 2 into 1. So simplify. 3 1s are 3 3s are 2 1s are 2 4s are 3 4s are 12 into 7. 7 2s are 14. Borrow 1 here. 7 1 7 8. So here 84. Now before we go ahead, can I increase the number to 5? Not possible. Why? Total number of girls are 4. Why we thought of increasing? Because at least get are equal to 3 girls. Correct? No, not possible. Because total number of girls are 4 in number given in the question. Okay. So now total this. What will be the total of this? 4. 4 plus 4 will be 8. So 588 ways. Total number of ways will be how many? 588 ways. Second sub problem done. Now comes next. At most 3 girls. You do one thing. Make a note of this. Let I erase. We'll do one thing. We'll try to complete here, because some of the data can be used. Okay. Third sub problem. Second sub problem done here. Okay. Now moving on to third sub problem. See carefully. At most 3 girls. No. So let us have a table. Let us have it here itself. I'll take a table. So again, girls. How many number? 4. Then boys. Totally how many number? 9. And here number of ways. Now see carefully, they have used the word at most. What's the meaning of the word at most? Let's write it here. At most 3 girls. At most means less or equal to 3 girls. So here, see one by one. So all less or equal to 3. So it can have 3 girls. We can have 3 girls. When we have 3 girls, how many boys should be there? So that a committee of how many? 7 can be formed. So it will be again 4. 4 plus 3, 7. This is done. Next, we have to go for lesser. Now decrease number of girls. If we have 2 girls, how many boys should be taken here? So that if I add this, I should get how many? 7. So it should be how many? 5. 5 plus 2, 7. Next, if we have now 1 girl selected, then we should have 6 boys. Yeah, we have 9 boys. No problem. 1 plus 6 is 7. Next, there are no girls in the committee. Then 7 boys will be there. 0 plus 7 will be 7. Yes, we don't have any. What? We have total number of boys 9. So we can have 7 in number. Okay. So now we have to go about. Now see, 4C3 into 9C4. 4C3 into 9C4. We already got 504. That's what I said. Let us have first whatever the thing, same thing is there. 4C2. 4C2 into 9C5. Let us see. 4C2 we have not computed. Let us compute here. 4C2 is 4 into 3 because only 2 is here. So 2 consecutive number less or equal to 4 divided by 2 factorial. So 2 into 1. So 2 ones are 2 twos are 2 threes are 6. So it will be 6. And now 9C5. Is it not 9C5? If I subtract this, I'll get what? 9 minus 5 is 4. Have we computed 4? Yes, we have computed. We have computed 9C4. What we got? 9C4. We have got it here. It is this number. Correct? No? 9 into 7, 63. 63 into 2, 126. We have already got that. Okay, so into 126. Okay, let us make a bit more space for this. For totaling. Into 126. Multiply. 6 6 are 36. Borrow 3. 6 or 12, 13, 14, 15. Borrow 1. 6 1 are 6, 7. Is that correct? 6 6 are 36. 6 2s are 12, 13, 14, 15. 6 1 6, 7. Yeah, 756. And again, I'll write 504 here so that while adding it will be easier. Next, 4C1. 4C1, no problem. See here. Out of 4, 1 girl is selected. 4C1 into 9C6. 9C6. See carefully. 4C1. Is it not 4C1? Yeah. Is same as. Anyway, 4C1 is 4 because NC1 is N. Next, 9C6. 9C6 is same as 9C3. Don't forget. This is same as 9C6 subtraction. So it will be 84. Multiply. 4 4s are 16. Borrow 1. 8 4s are 32. 32 plus 1, 33. Lastly, 4C0. Yeah, 4C0 into 9C7. Out of 9 boys, 7 boys to be selected. What will be the answer? 4C0. Have you got? No problem. 4C0 is 1 because NC0 is 1. How much is 9C7? Have we computed 9C2 sometime? No. Fine. 9C7. We want 9C7. See carefully. 9C7 is same as 9C2 and we can write this one as what? Let I compute here. 9C7 is same as 9C2, which is nothing but 9 into 8 divided by 2 into 1. 2 ones are 2 4s are 9 4s are 36. So into 36. 1 into 36 is 36. Total this. We have done with the problem. Just you have to add 6, 10, 16, 6, 6, 12, no? 12, okay, 22. Borrow 2, 5, 6, 7, 8, 9, 10, 11, 12, 13. Borrow 1, 5, okay, 7 plus 3, 10, 16, 160, 1632 ways. Totally how many ways? 1632 ways. This many ways we can arrange. This one is already computed here, so I have erased. In this many ways, it can be arranged. In case you have a problem of order, very simple, and I number it. This is your first thing to take. Okay, second. Then this entire thing is third, and then this entire thing is fourth order of copy. Okay, so make a note. Dear students, with this we have completed all the problems from the 3 model question papers. Not only that, we have went for each and every concept, and some problem I have taken from what? Exercise problem at the beginning, so that the thing should be very clear. Make sure study well, hard work, give your 100%. Okay, it's a very important time. I think you people will be having, most of you, 10th of February 2026 your annual board examinations. I'm talking about first PUC students. So I will make sure well in time all the remaining chapters also I'm going to upload the same way. Okay, so study well, hard work, be passionate, don't waste your time. Okay, write and practice. Make sure when after each problem is solved, put a pause, copy it. Okay, just don't be seeing, write and practice. That's very important. Okay, so God bless you all. Study well, do hard work, do share, like, subscribe to our YouTube channel Math Universe with Dr. Naseer Ahmed. Thank you.